Welcome, my name is Sebastian Hörl from IRT SystemX in France, and I want to present you a digital twin use case for parcel deliveries that has been elaborated in the LEAD project for the city of Lyon. And to give you a quick overview of this lesson, I will first set a bit the context, talk about the specific use case for the city of Lyon and what are the goals of this modeling. After, I will present you a demand model on parcels, which gives us information on how many parcels need to be delivered on a specific day in a territory. And then we pass on to the operational model, which gives us information on how these parcels are delivered by the operators, including emissions and costs and so on. And finally, I will show you a demonstrator of a platform where we have integrated these models so that they can be used and analyzed to look at various potential future scenarios of parcel delivery. So, to give you context on this digital twin, on the right you see the confluence area in Lyon, which is a peninsula, and the plan in the LEAD project is to set up an urban consolidation center on this peninsula. The plan would be that in the future, when this area gets further developed, it was an industrial zone before, that all the flows or many flows arriving in this territory will be routed through this urban consolidation center. And on the last mile, low emission and electric vehicles can be used to do the fine distribution in this area. In the project LEAD, we have developed a digital twin that will partly respond to modeling the system. However, we took a larger scope where we model all parcels in the whole territory around Lyon and check how they are distributed today and how they will be distributed in the future, given new pricing structures and giving new policies. And what we did here is we really focused on parcel deliveries because for this we already had methods and data available. If we want to extend the system to general goods, there's a need for new data acquisition and also more elaborate modeling techniques. For the modeling of the parcel delivery system, we first start with methods that we already know from the modeling of passenger transport in a city. We start with a synthetic travel demand, which means we generate households, persons, and their daily activity chains that are representative of the real population. And as you can see here on the left, we use a lot of data sets for this. So these are, for instance, census data. This is data, statistical data on the incomes of the population. These are address databases, household travel surveys. And we use all of these data sets to set up these households, person, and activity chains in a territory. Together with supply information, these travel demand datasets allow us to set up detailed agent-based transport simulations of a territory, as you can see here on the right, where we basically simulate the movements of all the people in the synthetic population, which gives us then patterns such as congestion or crowding in public transport. The noteworthy aspect of our approach here is that we can set up these synthetic travel demand datasets and populations based on open data. So all the datasets in blue that you see on the left, they are available publicly and as open data in France, although we can also enhance our datasets with proprietary data, which is indicated in black. But basically, we can set up these data sets with open data and open software because our process is open software, which allows us to do reproducible research on these kind of transportation topics. Because of this, the framework also has been reused recently by many different researchers in France. So we have use cases for Paris, for Lyon, for Nantes, for Lille, and for other cities, which also shows that what I'm going to show now about the modeling of parcel deliveries can be extended to other cities in France. As the next step in our demand data pipeline, we can make use of survey data, which looks at the purchasing behavior of the population. So for instance, what we see here is the average number of purchases per year by social professional category. So meaning if some household has members which are employees, workers, or retired people. And we have similar statistics where we cross also the age groups of a certain household with the type of employment of these people. Which means that we can link social demographic attributes of the population which we have in our synthetic data set with the number of parcels that are or need to be delivered during 1 year, and then also broken down to the daily level. This allows us to generate parcels for one specific day that need to be generated in the whole Rhône-Alpes region around Lyon. And we can also zoom down to the city of Lyon, and then we see all the parcels that need to be delivered during 1 day. The second big component of our digital twin is the operational model, where we first have used open data to identify all the distribution centers of parcel operators that are active around Lyon. Second, we have performed analysis on the market shares of all the parcel operators in the area, which allowed us to select each parcel and decide based on the market share from which operator does it need to be delivered. And then we were identifying the closest distribution center of each parcel's operator, which you can see here on the right. After, we were looking at cost structures, so we were checking for small, medium, and large vehicles with different capacities for parcel deliveries, and then also for thermic and electric vehicles. What is the price based on the capacity? And there we see, for instance, that usually conventional vehicles with the same capacity today are much cheaper than electric vehicles, which gives us a clear cost structure that we can implement into our model. We then let the individual distribution centers of these operators choose the vehicles, small, medium, large, that they need to use to deliver all the parcels that are in their responsibility, and they optimize the routes of these vehicles such that they arrive in a situation where they have the minimum cost. This gives us the composition of the fleet in each distribution center, and also other indicators like the total driven distance to deliver all the parcels. For those who are interested technically, we here solve a vehicle routing problem with heterogeneous fleet. And once we have solved this problem, we can estimate other KPIs, such as the total emissions produced by each distribution center and by the system as a whole, or for instance, the used electricity or energy in general. If you have any questions on these models, feel free to contact us at IRT SystemX. Thank you.